problem 11, which statement represents the relation shown at right? Well, this says that all four-legged things are horses. You can see four-legged things inside horses. All four-legged things are horses would be D. Okay, it's a good idea to think of the four basic relations between things. Some A are B. There's A, there's B. We just need one element there. Some A are not B. Same picture, but we're only really concerned with the existence of one element there. All A are B. That would have A as a subset of B. And no A are B. And this would have A and B as disjoint sets. Now, filling in the values of this truth table is a basic calculation. True or false would go here, and again, these values are fixed. We may have to fill them in, but we need to cover all four possibilities for P and Q. The OR statement is true when one or the other is true. So you can see one or the other is true in the first three cases, and in the fourth case, neither is true. The implication is false only in the case where the first one is true and the second one is false. That's false. The rest of these are true, true, and true. The AND statement, in order for the AND statement to be true, they both have to be true. Both P and Q need to be true. So this one is false, this one is false, this is the true one, and this is false. The if and only if statement is looking for equivalence, and you can see here T is not equivalent to F. Not equivalent, not equivalent, equivalent, equivalent. Again, just calculations. Now in numbers 13 and 14, there's a couple ways we can go on this. The most basic way is to determine if these two statements are equivalent is to see them in a truth table, and you can see whether their columns have the same values. Okay, so for example, the statement P implies not Q will show up right here, and you can see I have a helper column here. And to get not P and Q, first I'll get P and Q, and then I will negate it in the next column. Okay. And there's four possible values, TT, TF, FT, and FF. And so we'll fill this column out, and we'll look to see whether the values here are the same as or not the same as the values here. If these two are the same, they are equivalent. If anything differs, they're not equivalent. So let's see, not Q would be false, true, false, true. P implies not Q, P arrow not Q, here to here. That would be the false case. T arrow T is true, false arrow false is true, and false arrow true is also true. P and Q, again there's the true and true, and that's false. False and true is false. False and false is false. And now the negation of the previous column would go here. False, true, true, true. If we look at the entries in this column and the entries in this column, we can see they're equal. Therefore, these statements are equivalent. The next one is very similar. We have two statements. We want to see if they're equivalent or not. And again, without any algebra, the easiest way is simply to put them into a truth table. So I'll put not P arrow Q here. There's a little helper column. And then I'll put Q arrow not P here. True, false, false, true, false, false, true, true, any order. The negation of P column would be false, true, true, false. Now we have not P implies Q. We're going to go this way from here to here. False, arrow, false. That's true. True, arrow, true is true. True, arrow, false. That's the one false. And false, arrow, true is true. Now Q implies not P. Q, arrow, not P would go here. True, 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 and false. And you can see here these two columns are not equivalent, and therefore the statements themselves are not equivalent. Number 15 has us dealing with statements P and Q, and you can see by just looking at them, 8 times 4 is 32 is a true statement, whereas 10 minus 6 equals 5 is a false statement. And we're asked to calculate the value of not P implies Q. Well, the value of P is true, so it's not true implies the value of Q is false. And we know that not true is, of course, false. And the value of false implies false is true. So this is a true statement. Okay, number 16 asks us just to diagram an argument, not to determine whether it's valid or invalid. In this case, we're given if I smell bad, then people will not stand near me. So I smell bad certainly is simple statement P. People will not stand near me could either be Q or not Q, depending upon what Q is. So we could call this P implies, and we could start with maybe not Q, where Q is the statement people will stand near me. The next premise is I don't smell bad. That's not P. So if we were to diagram this out, we would be looking at P arrow, not Q. I don't smell bad is not P. Therefore, people will stand near me, which is Q. And let's check to see if this matches any of them. P arrow, not Q, it doesn't match this one. P arrow, not Q, not P, therefore not Q, doesn't match that one. P arrow, Q, not P, therefore not Q, it doesn't quite match that one. And certainly it doesn't match this one. Okay? You see, the reason why this one is struck out is because we expect that these two should be negations of each other. And in this case, they're the same statement. Here they are negations, and really it's just a matter of what you call Q. If I allow Q to be the compound statement, people will not stand near me, then not Q is people will stand near me, and we can see then a diagram of the argument might look like P implies Q, not P, therefore not Q, which is answer C. Sorry about that, you can see that a little bit better here. Okay.